welcome to the last section in chapter 3. So after this, you will know all things about lines. And we're going to add on and just kind of build of our knowledge of slope-intercept. I'm going to introduce this form called the point-slope form. And we're going to touch on both parallel and perpendicular lines. There's one challenge question that I put on the homework, and I will show you one example of the perpendicular lines, but we don't spend a lot of time talking about these things. But it's good to be introduced in case it comes up again in some future math class. So slope-intercept, we're familiar. M is the slope, B is the y-intercept. So we've already done this, so this is just a review. Find the slope and y-intercept of this equation. We need to solve it for y. So we're going to subtract 3x from both sides. We get 5y equals negative 3x plus 20. And then I'm going to divide all three pieces by 5. So I have y equals negative 3/5 x plus 4. So my slope is negative 3/5. My y-intercept is positive 4. All right, so let's graph a line. Some of this is review. As you've seen throughout this whole chapter, there's just some overlap in the sections. So graph a line with slope of negative 3/4 and a y-intercept of 0, minus 5. Remember, when we graph, we're always going to do the y-intercept first. So the instructions here look a little different, but what we do does not change. So let's go down 1, 2, 3, 4, 5 and put our point. And then we have a slope of negative 3/4. So down 3, right 4, or up 3, left 4. Your choice on how you're going to do that rise over run. So down 1, 2, 3, over 1, 2, 3, 4, or up 3, left 4. The reason I keep talking about that over and over again is because sometimes you run out of space on your graph, and so it makes sense to go in the other direction. And then remember your little arrows right there. If we graph x minus y equals 2, and we solve this for y, minus y equals minus x plus 2. So divide by -1, divide by -1, divide by -1. You don't have to go through all of that. It basically just has the effect of changing the signs of everyone. So this negative changes to a positive x. Notice how the y changed to a positive y. And then this is going to change to a -2. So go down 2 and plot your point. And then remember, my slope is just a 1 over a 1. So up 1, right 1, or down 1, left 1, and draw your line. Kind of missed. Sometimes the errors don't show up until later. Like this one should go through all of these diagonal corners exactly. All right, our next problem says, now we're going to reverse it. I don't think we have done ones like exactly like this yet. It says, state the equation in slope-intercept form given the graph. I know there are problems like this on the homework because I chose them. So we want to make sure that we need those two pieces. We need the slope and we need the y-intercept. This one you can just pick off the graph. So that y-intercept is just right there. Where does it cross the y-axis? So we're going to add 35 to the back. Then we're going to count out our slope. So even if we have to go down and to the right a little bit extreme, we can reduce that fraction. So we're going to go all the way down 35. And then we're going to go right 10. So negative 35 over 10 reduces to, and don't forget your x, reduces to negative 7 halves x plus 35. Okay, so now, sorry, I had to pause there. So if there was an awkward gap transition there, I paused and came back. So now we are going to find the equation of this line. So notice how this line doesn't have any points really defined. So we need to do that definition. So I see that we need to pick out that y-intercept. And then I need to pick out the slope. So like I wouldn't pick right there because it doesn't really go through the corner. So let's find a place. I tried to make this kind of defined. Goes through that corner there. My skill in this area with this tool is not exact, but it goes through the corner there. You can see that if I kind of go up 3 over 1, it's going through the corners of the graph. So when I go to write my equation, y equals, my y-intercept here is negative 2. And my slope, I went up 3, right 1. So 3 over 1x minus 2, or you don't have to write that as a fraction if you don't want to, negative 3x minus 2. All right, so now we get into a pretty big skill, and this comes back. I review all of this information in chapter 7, so we are going to utilize this skill in our next chapter as well. And in order to find the equation of the line given 2 points, not only do we need the slope-intercept form, but we also need a form of the line that we haven't looked at yet called point-slope. And it's still a line, it's just written a little bit differently. And I wasn't able to write these little subscripts in when I was typing. So we need to put a little 1 there and a little 1 there. And then I typed out the steps for us already. So number 1, we're going to take our 2 points and we're going to find the slope. Then of the 2 points, we're going to pick one. So step 2 is super easy. You just choose the one that looks easier. And then we're going to plug into this point slope form. So we're going to plug the slope and the point in for those pieces right there. And then our very last step will be to solve for y. So let's go through this. And I'm going to go through it twice, and then I have an example for you. So step 1, find the slope. Instead of 1, I'll put m for slope. So we're going to have minus 1 minus 3 over 3 minus 2 for my x1, y1, x2, y2. So my slope is negative 4 over 1, or just negative 4. I'm going to choose a point. Given the choice of these 2 points, they're both pretty small numbers. I would pick one that had a 0 if possible. I would pick ones that don't tend to be negative. If there were fractions, I wouldn't pick the fraction or the decimal. So this is going to be my x1, this is going to be my y1, and this is my m. And I am going to plug into this point slope form that I had written above. So y minus y1 is 3 equals, the slope goes next, negative 4, parentheses, x minus 2. Multiply through by negative 4 here, because now our very last step, you can see the steps peeking out from up above here. The very last step says solve for y. So we need to get y by itself, and we want to gather all these like terms. So the first way to do that is to distribute. So we have y minus 3 equals negative 4x plus 8. And then I'm one step away from being done. Just bring that 3 to the other side by doing the opposite. And so y equals negative 4x plus 11. Let's do that again. first step is going to be to find the slope. So -1 minus a -2 over 6 minus 4. So change the signs there. It looks like I'm going to have 1/2. Choose a point. Well, I'm going to have to deal with a fractional slope. So I'm going to choose this point because it has two evens. And that way I run, this one would have worked fine as well because the x is even. But just if you're not seeing that full picture yet, I'm going to pick this so that I end up, any fraction that's going to come my way is going to cancel out. There is a negative in this point slope formula, and my y value here is -2. So this is my x1, y1. And if there's a negative there and a negative there, this is going to change to a plus. My slope is -1/2, and then I have x minus 4. Multiply through by that -1/2, and I get -1/2 x. I have -1/2 times -4, which turns into a +2. Oops, I accidentally changed colors there. And so then I'm going to subtract this 2 to the other side, and I get y equals -1/2 x. And then the 2's drop out, so you can add in that +0, but normally we would just leave it as is. All right, you can go ahead and pause the video and try this. My slope is going to be -5 minus 0 over 0 minus a -4. So sometimes having zeros in those coordinates can be a little confusing because we have two negatives here, so it's going to change to a plus. So there is our slope. I am going to pick this value right here because x is 0. It's going to work. You're going to get the same answer regardless. Here's going to be my x1, y1. And so y minus y1 equals -5/4 x minus 0. So now I don't have to distribute this fraction because that's just going to be a 0. So it's going to work out to just not have to worry about multiplying fractions is my babbling point there. So -5/4 x, and then -5/4 times 0 is nothing. Let's take that 5 to the other side. So y equals -5/4 x minus 5. What if you picked the other point? So if you want to see it worked out, I'll work it out for you with this point. It would be y minus 0. Maybe some of you thought this was easier. Maybe it is. -5/4 x minus a -4, or x plus 4. So now we do need to distribute, but the upside is we have the y by itself. So we have -5/4 x. It looks like I said 14 there. Let me see if I can't clean that up. That's supposed to be a positive. So +4, because two negatives make a positive. When I go to multiply here, these 4's cancel. And so then this actually does just become -5, which, as you can see, it was the exact same. It doesn't matter which way you do it. You get the same equation. Okay.